Alright, the zero product property. Yesterday we kind of talked about how we had x-intercepts. What were some other names we used for x-intercepts? Solutions, zeros, roots. You need to remember that all of those are true for any quadratic or any solution there. X-intercepts, zeros, roots, solutions. Today we are going to find the zeros of each function. We are going to be working with quadratic functions for a little while. So we're going to, just to get the point across here, we're going to remember that zeros is also roots, x-intercepts, and solutions. There's a reason they're called all of those different things, but you need to know that anytime they say any of those words, it's talking about all the same thing. Which means, if it's an x-intercept, you could graph it and look at the x-axis. If it's a root, we'll talk more about roots later. You know, like a square root, that's a root, that's what it's talking about. Zeros, they are called zeros today because we're talking about the zero product property. And the zero product property says if you have two things multiplied together and they equal 0, then that means one of these has to be 0. Because what is anything times 0? 0. That's what the zero product property says. So we are going to look at some examples of this. So the first one we're going to look at, we've got a function f of x equals x minus 15 and x plus 7. Our goal is to find the zeros, which also technically comes where it comes from. Which means I could graph it if I find out where it's across the x-axis. There's a lot of things you can do with these equations. Alright, I am supposed to find the zeros. So based on the zero product property, it says to find the zeros, or if we're looking for zeros, it's true that that one of these has to equal 0. So we're going to go ahead and set this equal to 0 in general. Sometimes it will already have equal 0, but to find the zeros, we have to set it equal to 0 if it's not already like that. Alright, and then this property says if you have two things, or actually it doesn't matter how many things you have, multiplied together and they equal 0, then what's got to be true? What does this tell us? Either one of them has got to be 0. So we're going to, these are A and B we're pretending here. That means we're going to set each of these equal to 0, and we will find our two zeros, roots, x-intercept solutions. So now it's just a one-step equation. How do I solve this equation? Add 15. So what is 1, 0? X equals 15. That's one of them. We also, it makes more sense. You're used to hearing that's the solution. That's the answer. Okay, how do I find the other one? So x equals, that's the other one. Some of you eventually will notice a pattern and not have to write all that down and work it out. I'm pretty sure you probably could notice it now. What's true about these compared to up here? They're just the opposite signs. Yeah. Alright, number 2. F of x equals x plus 1 times x plus 23. We are looking for the zeros, so this actually should be set equal to 0. Now what do we do to find the zeros? Yeah, we can send up x plus 1 equals 0. We subtract 1. So what is one of the solutions? Negative 1. Set the other one, x plus 23 equals 0. What do we do? And so the other one is negative 23. Good. I'm going to put up number 3 and 4. We're still on page 104. We're putting something else on 105. These are the last two that are going on that page, though. So try those two. Alright, number 3. What do you guys think we need to do? X equals 0. Yes. You don't have to keep rewriting this over and over again. But all I'm doing is I set each piece equal to 0 because I'm looking for the zeros. Do I have to do anything with this one? No. Don't forget that exists because you have one left out on your homework and people forget that, oh yeah, it's just x equals 0. Alright, then what do I do on the second one here? X equals negative 12, okay? Alright, what did you guys do on number 4? Set both up to equal 0 since we're looking for the zeros. X equals positive 10. X equals 6. Alright, good. Now, before you think this is way too easy, we're about to do not something that's harder, but throughout next week, we are going to add things to this. Eventually, we're going to get to the point where we find out how we get into this set of binomials. We'll talk about that next week. Alright, page 105, we're going to do some more examples that are almost the same, a little more complicated. So. On page 105, we are starting something that's actually called factoring by grouping, but it's actually already grouped for you. You're going to see what I'm saying. 105, the title is the same if you haven't written it. The instructions are to solve each equation, which is the same as finding the zeros because it is a solution. But now they're actually going to be written as equals 0 instead of f of x. So here's number 5. 3x times x minus 4 plus 5 times x minus 4 equals 0. Why don't you write that out? Explain what factoring by grouping means. Alright, factoring by grouping is looking at, without looking at the parentheses right now, we have one operation right here, this plus. What do these two things, this 3x and x minus 4, and the 5 and x minus 4, what do these two have in common? They have what? They both have an x minus 4. Good idea to get a highlighter or something out. Box that in. That's what they both have in common. We are going to bring that down. When we bring it down once, we are done with it. It's like it's factoring it out. It's like dividing it out of there. What is left? 3x plus 5 is what's left. Right here, 3x plus 5. And you guys said equals 0? Just bringing that down. We have now put it into the form that we saw just a second ago. That's the new step, is to factor. It's like factoring by grouping. We pull out what is together, multiply it by what is left over. Which would have been the same thing, because you know how I distribute 3x to the x and to the 4, that's where this comes from. And distribute the 5 to the x and the 5 to the 4, that's where this one comes from. Alright, so now if I'm doing it just like before, how do I solve this now? I do what? Do the same thing that we just did, which is equal both to 0. The only difference is now we also have a two-step equation instead of just a one-step. So how do I solve this one? Add 4. So one of the answers is x equals. Okay. What do I do with this one? Subtract 5. So 3x equals negative 5. Divide 3. X equals, leave it as negative 5 over 3. Alright, number 6. Negative 9 times x plus 2 plus 3x times x plus 2 equals 0. I'll bet you can see that. While you're writing that, I want you to think about what is a like that you're going to factor out. When I say factor, the actual math that's taking place is dividing. Number 6 then. What do both of these terms have in common? There are 2 of these x plus 2's. They both have 1. So what am I going to do with it? Bring it down. Okay. Somebody said then what? And that equals 0. Okay. Then what do you do? Set them both to 0. X equals negative 2. Okay. Add 9. So 3x equals, then what? Divide by 3 and x equals 3. 9 divided by 3 is 3. So you have x equals negative 2, x equals 3. I want you to do the next 2. I'm going to come around. If you need some help, please ask for it. We're not doing anything other than this now. So I want you guys to do 7 and 8. Okay, you said we set up 7 by doing x minus 11. And then you said 7x minus 2 equals 0. Okay, then what? Both of them need to equal 0. Okay, now what? Add 11. X equals 11. Okay. X equals 2 over 7. Okay. You can always check if something reduces, this doesn't, because they're both prime, but it's always a good idea to see if you think something, hey, will that reduce or not? Right, how about number 8? Okay, x plus 6, and then negative 8x plus 3 equals 0. Okay, then what? X plus 6 equals 0, negative 8x plus 3 equals 0. Okay, now what? Subtract 6, okay. When you have a negative divided by a negative, what happens? It's positive 3 over 8. Positive 3 over 8. Alright, your homework is in your book again. I say homework, but you have 15 minutes, and as you see, those didn't take long either. Page 966, 1 through 12. Page 966, 1 through 12.